My name is Noah Carlisle. I'm an electrical engineer and I graduate in 2028. So the eShop here at the Makerspace is separate from the rest of everything, and it has no windows or anything like that. So in order to bring it more alive, we tried to incorporate plants into here. An issue we had though is that people kept forgetting to water the plants. So what we decided to do is create an automatic watering system for them. Developing the chassis for this system was a unique challenge because it involved the culmination of so many different machines that we have here in the Makerspace. So we 3D printed the bottom of the chassis using a Prusa Mark IVS that we have, and then the top of the chassis is laser cut in-house as well. One interesting challenge that we face is going from the 5-volt logic that the Arduino operates on to the 12-volt logic that the pumps operate on. So we had our electronic shop lead, Josh Hockey, come in and develop a custom circuit in order to do this.
I'm Joshua Hockey, graduating in 2026 with a degree in electrical engineering, and I'm the lead of the electronics shop in the Makerspace. To build the circuit that controls the water pumps for the plants, we needed a way to switch a high voltage, high current load. And to do that, the first thing that came to my mind was using a MOSFET, which is kind of like an electronic controlled switch. And so I did a prototype of that circuit, made sure it could switch the appropriate voltage, and then had to go through a few iterations to make sure the circuit would work with the Arduino.
We could have used relay boards like this in order to go from our 5 volts to our 12 volts, but we were seeking a more elegant solution. The way this works is the Arduino sends a 5-volt signal to our little moisture sensor here, and then it reads back how much voltage it's receiving. Depending on the moisture in the plant soil, this will be a high reading or a low reading. And from that we derive our 2 to 3 digit moisture value that we have displayed on our screen here. So once we receive our signal back from the plant sensors, our circuit board decides whether or not to turn the pump on. So once it does that, it'll send a signal over to our other circuit board, and then that will take it, power on the pump, the water will travel up, moisturize the plant, and then once it goes back to the threshold that we want it to meet, it will turn the pump off.
So we're sitting here looking at these plants, and they need to have names. And you know, it was kind of a game of the first things that come to mind. And so it was Meatloaf, not after the food dish, but after the singer from the 80s. And then there was white chocolate mocha with half and half because we got it during Christmas and Starbucks was handing out Christmas cups, and we were gonna put the succulent inside the Christmas cup. So the snake plant was too big and had to be divided up into 3 parts. And so what electrical engineering thing kind of has 3 components, and it's operating systems. And so with those 3, you have Windows and Apple and Linux. And so we named the plants after the founders of those companies with their last names as those companies.
This project has been so much fun to work on over the last couple of months. I've really enjoyed every aspect of it and getting to use such a diverse skill set in order to achieve a goal. I'm very fortunate to have all the resources that the Makerspace provides, and I couldn't think of a better place to work. Thank you guys for watching.